In our last lecture, we were discussing permissions. At the end of the lecture, we started introducing the concept of the special permissions. These permissions are used in unique situations, and they're traditionally used in the file system for granting access to files or folders that we don't have privileges to normally. As we know, the typical permissions that we use on a regular basis include read, write, and execute. Those are the three basic permissions, and we could apply those permissions to three different objects or entities in the file system. Users, oops, not O, take that back. Users, groups, or everyone else in the file system, or the others. And each of those have three positions where they can hold permissions. So we could have read, write, execute, read, and execute, read, and execute. And you should know that those would equal 7, 5, and 5 numerically. Now there are other permissions that we can assign to either the user. So we can assign the set UID permission to the user. So set UID. To the group, it would be the set group ID. And to the others position, we can assign what's called a sticky bit. Those permissions can be assigned in these positions and affect how the users interact with files and folders. The key thing when remembering to assign these permissions is that they're always added to the same place as the execute permission. And that's kind of peculiar because we actually end up with 4 different permissions in a particular entity, possibility here, in the user, in groups, and others, but we only have 3 positions. So, what you'll notice when using these special permissions is that when you add a special permission to the position that contains the X or execute permission, that permission will show up as a lowercase, as opposed to if you add it where there is no execute. For instance, if we would add the sticky bit, eliminate X, say there is no X there, and I add the sticky bit to that position, it would actually show up as a capital T, not a lowercase t, as we're used to seeing with other permissions. So let's go ahead and take a look at these and see how they're used. I'll clear my screen. And I will now go through, and what I'll do is create a group. I'm going to create this sales group and a directory, and then we're going to go through the process of making sales, the group, the owner of the directory. Alright, so let's go and make the sales directory if it's not made already. Do an lsshld on /sales, and here we can see the permissions. Default permissions. Remember, all directories start out as 777, and the umask is used to remove the write permissions from both the group and the others position. So that's where that 2 and 2 come in there. This 0 that you see here actually represents where the special permissions could possibly be placed within the umask. So if you wanted to extract a special permission, which is, fairly unusual to happen, you could technically set up a umask that would do that. So right now, as we see in the default, we have root, the user is the owner, and the group is owned by the root group also. So sales, as it is right now, is owned only by root. So the first thing we'll do is add a group, sales. The next thing I'll do is change the ownership of the sales directory to the sales group. So we'll chown And we'll actually take out root as the user owner because that particular account doesn't need to be there. And then we'll make sales the owner, the group owner. So we'll have nobody colon sales slash sales. So here I'm saying I'm changing the ownership. The user owner will be the nobody user, and the group owner will be the sales group. Press enter, ls-ld here. Alrighty, so we've accomplished our first task to change the ownership. The next thing we want to do is change the permissions so that only sales has access to this folder. And the easiest way to do it, and I could have done it when I created the sales directory, I could have typed make dir m070, right? 0 for the user, 7 for the group, 0 for everybody else, /sales. That would have worked. But we're going to play with the smod command, and we'll say 070 /sales, and press enter. Do an ls-ld. Oops, forgot the L. And there we have our permissions. So they look good right now, but before we can actually say that they're correct, we need to create some users and put them in the sales group. So let's go ahead and do that. And while I'm creating the user, I will add them to the sales group with a capital G. So I'll add a Jane user and we'll say Ben user. And notice I made Ben with a capital B, which is not normally how we would do it, but it's perfectly fine here. And then we'll password Jane. Press enter. We'll give her a password of work, and then we'll set the password for Ben also. All right, and what we'll do is flip to another terminal just so we can log in as that user. So we'll log in as Ben. And then we'll exit out and log in as Jane. Slip back to our GUI, and we're ready to test our permissions. Control L, clear our screen. So I'll ID Ben, and we can see that Ben is now a member of sales. And what this group membership, I know we've discussed this before, but the group membership is very important. You take users, you put them in groups, and then apply permissions against the groups. This way, if you need to add more users to a particular, give users access to a particular directory, you can do so easily by putting them in the proper group. And that's all we've done here with Ben and Jane. And we'll ID Jane, and we can see Jane is also a member of sales. So let's test it. We'll open up, we'll go to another terminal, Shift Control T and Shift Control T, and we'll open up two. And in this one, I'll issue in as Ben. Alrighty, and then the next one, I'll issue as Jane. Now they both have access, so let's CD into sales. Oh, and by the way, if I open up another terminal and we're logged in as student and I try to CD into sales, student's not a member of sales, and I should get a permission denied, and I do. Because the only people who are the only users who are members of the sales group are Jane and Ben. So right now, with the permissions we've applied towards that directory, nobody else can is granted access. The only one who could get in there right now would be root, because root does have access to the entire file system. Alright, so let's go back. Let's look at, first we'll look at Jane. So Jane is in the sales directory, and Jane can touch the Jane file. And then we'll switch over to Ben. And Ben can touch or create a file. Oops, we weren't in sales. So let's see these sales. Let's try that again. So we can see both files created by both users in the sales directory, right? So pwd, just so you can see where I am in /sales. The problem with this is that they're both member of sales in the sales group, but if we look at which group owns these files in this directory, in the sales directory, it's not sales, it's Ben and Jane. And that's a problem because of the permissions, right, that can be applied to these particular files. We want to make sure that when files are saved to the sales directory, it's automatically changed ownership to the sales group. Logically, if you put everything in the sales group, in the sales directory, it should be owned by members of sales. So what we want to do is use some of the special permissions. And there are 3 special permissions we can look at, and we'll look at all 3 of those. Now, the first one, and we touched on this last lecture, is called the set UID, or the user ID bit. Either way, what it means and what its purpose is that when that permission is set on a file or folder, anyone having access to execute that file or folder, run it with the permissions of the user owner. Now, a perfect example of this is when you, as a user, let's say student, for instance, or Jane, we'll switch over to Jane. If Jane wanted to change her password, all she would have to do is type password, and then a prompt would come up asking her for her current password and what password she wants to change it to. So I'll put in my current password, which is work. And I'll add a new password. And this is one of the problems you come across when you're a normal user. Because of something called password complexity, the policy that's set, Jane has to really have a fairly complex password to be set for her. So let me see if I can make one that's a little more complex. I'd like that one. Alright, and Jane has been able to change her password. Now, that seems logical that she can do that, and it is, but it's interesting once you actually see the file that she's editing. If I type ls-l etc shadow and press enter, whoops, gotta put an L in there. You can see this is the file that Jane actually just edited with the new password. Well, how's that possible? If you look at the permissions, she has absolutely no rights to that at all, even in the others position, and it's owned by root, user, and group. So how is that happening? Well, it happens because of the fact that the password utility, the actual little application that I ran when I typed to change my password, has the set user bit set on it. So let's go in there and look at that. And sure enough, if you look at this file all the way over at the user position, because remember it is the set user bit, where there normally would be an X, there's an S. That S in that position says that when I type the password utility as anybody, it runs this utility from this location, and that utility runs with the privileges of the owner. And in this case, the owner is root. So Jane or anybody else in the file system can change their password even though they have no permissions to the file that they're editing, because they're picking up their privileges through the user account root. It's temporary, but it allows me to run applications that I may need to run to function properly on the system, but I don't want to be given full root privileges to do this. I just want temporary, very fleeting privilege to run that application. So the set user bit allows that to happen. And that's typical on the system where it's used. So whenever you have an application that must run in the context of root, when it runs, but you don't want to be given root privileges to the users, you can do that. Very unusual, usually set by the system, but it can be set by the administrator also. So that's the set user bit, right? The set UID bit. Let me write that out, make sure we all understand exactly. So the set UID bit completes that. Right, the next one that's available, right, is the set group bit, or the SGID bit. That bit, when set on a file, would do the same thing as the set user bit, but it's not used in that way anymore. Usually where we set this bit is on a folder, like sales. And we set it on sales so that when a file is saved into that folder by someone like Jane, when Jane saves a file and she's a member of that group, when that file is saved inside the folder, it actually, the group ownership is changed from the Jane group to the sales group. This allows us as administrators to easily change group ownership based on the ownership of a directory, and that's very, very convenient. So let's take a look at that and modify our folder. We'll clear this out. And we'll do an ls-ld on sales. Once again, here, sales owns it now, but that set group bit is not enabled. So I'm going to smod, and think about it, it's the group bit, so it's going to be G plus S, right? It makes sense, /sales. Now watch what happens there. There's the X right now. I'll press enter, up arrow, enter, and sure enough, there's the lowercase s. So before, when we were in here, and we'll go back in there now, sales, do an LSL. When Ben and Jane saved their files, it was saved under the Ben group and under the Jane group. Now when they go in and save files, let's try it again. I'll say Jane 2. And I'll go over to Ben and say Ben 2. Do an ls-l. Now, when you look at those files, you see that Ben, the user, owns it, but sales, the group, owns that file, and the same thing happens here with Jane. And that's happening because of this permission right here, the set group permission. There is one other problem. The write permission has been set on the directory for sales. Well, Ben and Jane are part of sales, so they pick up the write permission to a directory. And as you remember, when set on a directory, the write permission allows users who are given that permission the permission to delete any file or folder within that directory, even if they don't own it. And I want to prevent that also. So to do that, that's where the sticky bit comes into play. The sticky bit says, when set on a directory, only allow the user owner to delete that file. So even though Ben and Jane are both members of sales and therefore pick up the write permission to the directory, because I'm going to set the sticky bit on that directory, only the user owner Ben will be able to delete his files, and only the user Jane will be able to delete her files. And this, once again, is a very common permission to see set on the system. And if I go out, show you a very typical place it's set. Here you can see it right here on the temp directory. Now, temp is a place where every user that logs into the system can save files, temporary files. Now, it makes sense that I shouldn't be able to delete somebody else's files if they've created and need it for temporary usage. So that T bit, and notice that it's a lowercase t. That T bit is saying that only the user owner on that file can delete it. Now I'm going to smod sales and change it so that I have the T bit set right here. Remember, the T bit, which is sticky, and don't ask me why they went from S for user, S for group, and then T for sticky. I have no idea why they chose that, but they did. So you just have to remember that sticky is not an S, it's a T when you want to set it. So I'm going to smod the directory. I'll clear it first. I'll smod, and I'll say others plus T, because remember, it always goes in the other position, right? So you have set user, set group, and then sticky. And I'll say it's on the sales. Yep, can't do that because I am not root. Flip over the root and try it again. So smod O plus T / sales. And /LD / sales. And there's the sticky bit set. Now I want to show you, doing ls-l temp here. Not in temp. And again, dtemp. And then I'll do an ls-ld sales. Notice, on temp, the T is a lowercase t. On sales, it's an uppercase T. And why is that? Because on the temp permissions, there's also an X there. Remember, there's only 3 positions, but there's 4 permissions I can add to that. So what they do is they indicate that actually 4 permissions are there. We know that because it's a lowercase t. And think of it this way. If the T and the X have to share a space together, they have to get really small to do that, so they're lowercase. If you see an uppercase T or an uppercase S, and those are the only letters you'll see uppercase, by the way, all the special ones, that means, in this case, there is no X set there. So the T can stretch out and use the entire position to itself. Just a little way to remember what permissions are actually being set. Well, we've set the T permission, we have the S permission. Let's go check it and see what can happen now. So we'll switch back over to Ben. Now, I'm going to try it without logging out. Now, recommended, since Jane and Ben have already logged into the system and been authenticated, and they've already accessed sales, sometimes I've changed the permission on this directory, but they were already in the directory. So sometimes those things won't apply to users currently logged on and accessing a directory. You literally have to disconnect the user or force them to log back in. Now we're going to test to see what happens when we do this. So let's try it. So we'll do a touch Jane file 3. Press enter, ls-l, and sure enough, there's the Jane file. There it is. And let's flip over to Ben now and see what happens when Ben says rm-f Jane file 3. We did not have to log out this time. So Ben was not able to do it this time because we set the sticky bit. The reason that Ben cannot do this is because of this bit set right here. He cannot delete that file with that permission set. And that's the power of the sticky bit on a directory. Now, remember, when we do UMask, we actually see that we can use numbers to describe these bits. And I'll show you how you can find what numbers are represented by the bits. If you man smod and press enter, and then we'll search for sticky. And I'm sorry, my screen is a little off here, so you can't see that I'm searching for sticky at the bottom. If we search for sticky, we actually see that we can see the special permissions. So the set user ID bit is a 4, and that's understandable because user is a 4-letter word. The group, and you can think of 2 or more as a group, is a 2. And then sticky, like a stick, 1 stick, baseball stick, softball stick, you know. Well, those are bats, but we'll go with that. That's a 1. So the sticky bit is a 1, group ID is 2, user ID is 4. So we can use that information to set permissions. So let's say I wanted to create the HR directory and set the permissions on it. Well, I could use the mod, and let's say I wanted to set the exact permissions of group 2 and sticky with 0, 7, 0. Well, that would be 3, 0, 7, 0. Remember, this first position that we see over here that we normally don't discuss is where the special permissions go. This is the user, this is the group, this is others, and these are the special permissions. And I'm using the numbers to describe those special permissions. So 1 for sticky, 2 for group. And what we should end up with when we create the HR directory is exactly what we created for sales in the longer way of doing it. So using numbers really is a convenient way when initially setting permissions on a directory. Now, you'll notice the one thing that didn't happen here, the group ownership hasn't changed, so it's not doing very good for us, so we'll have to create a group add HR, and then we'll chown, and this time we'll just make it HR, the group, won't worry about the user, /HR, and then we'll use user mod G, capital G, HR, Jane. We'll put her in that group too. They're popular. They're going to be in all the groups, and Ben. And so now if we ls-ld on the HR directory, sure enough, we see the permissions, we have the ownership, and we've set that one up fairly quickly. So that's permissions at a basic level. Now, there actually is another level of permissions that I'm not going to discuss in this class, and that's something called Facults, which allows me a more granular application of permissions on the file system. Instead of just having user, group, and others, I can actually create groups, multiple groups, and give those groups permissions independently. Very much like we would do in a modern operating system like Windows. If you're familiar with the way Windows handles their ACLs, it's very similar to that. So that is permissions and access permissions on the file system. Next week we'll be moving on to another topic. There are some exercises in your book that you can use to play around with these. I encourage you to do so and see how you can manipulate the file system.